In this video, I will talk about the usefulness of the concept of the electric potential and why we like to use it more than the electric field. We have seen, for example, for the electric field from a single point charge, we have seen that this is the expression to calculate the electric field. We have the constant 1/4 pi epsilon naught. We have the charge Q1, that's the source charge that creates the electric field, and we have the magnitude of the r vector from 1 to 2 squared and the unit vector. One of the most important drawbacks of using the electric field is that this is a vector, and anytime you have a vector, in order to fully describe that vector, we need three numbers. And one example for those three numbers could be the x, y, z coordinates if you're using the Cartesian coordinate system. So to describe the electric field vector, we always need three numbers in order to have it fully to have its full description. Now, because the electric field is a vector, that means that we also need to calculate vectors. So here the r hat is a vector, and also the r vector that goes from 1 to 2, that is also a vector. Of course, we do take at the end the magnitude, and that becomes a number, but we have to calculate the r vector that goes from the source charge to the observation location. So when we want to calculate the electric field vector, we have to work with vectors, and that means that we have to do several calculations, and we have to keep in mind, if you want, what the three numbers that fully describe the electric field vector are. So several numbers, several calculations, and that makes our lives a little bit more difficult than what we would like. Now, in addition, if you want to measure the electric field, again, you have to measure experimentally three numbers. And one example could be you will need to measure the EX, you will need to measure the EY, you will need to experimentally measure the EZ. Okay? If you want to experimentally measure the electric field, you will need to measure three numbers, not just one. So this is in contrast with the concept of the electric potential, and for that we use the uppercase V symbol. This is an uppercase V. This is a single number. So if you want to calculate it, you're going to be working with numbers, and you will be calculating a number. If you want to store the information about electric potential at a point, you need to store a single number, and that is 1/3 of the information you need to have about the electric field vector. Now, in addition to that, when you measure it, the only thing that you will measure experimentally is the potential, and that is a single number. So here we had to measure experimentally three numbers. Here, the only thing we need to measure is a single number. So these are the reasons: calculation, information storing, easier to measure it experimentally. These are the reasons why the concept of the electric potential is preferred than the concept of the electric field. Even though the electric field does, we do use it quite often, but if you have the choice, working with electric potential will make your life easier.